Hey everybody, how's it going? Back here with another video for you. Made it to 300 subscribers, so that's pretty exciting to me. So thank you to all my subscribers. So I didn't just make this video to say that. We have an actual topic today. So today we are talking about digital signatures and how it relates to Bitcoin and how it relates to signing transactions. The reason why I wanted to make this video is because when I was online reading, the forums and the discussion groups and reading articles and crap like that, I saw a lot of people referencing the idea of signing a transaction. And all I understood about this concept of signing a transaction was the fact that by signing a transaction, you are verifying that it is a legit transaction and that this person who is signing it is the rightful owner of the bitcoins that are referenced in the transaction. And this concept applies to pretty much any cryptocurrency out there. So what we could be talking about Ethereum or Fedora coin or Happy coin. It could be any of those, it doesn't matter. They all run on the same concept in this case. So in order to understand the concept of what is a digital signature and what does it mean to sign a transaction, we have to understand public key encryption. So the essential concept of public key cryptography is that you start by taking a random input and you generate a pair of keys, a public key and a private key. The public key, as the name suggests, is public and anyone can see it. The private key, as the name suggests, is private. It's secret. Only the owner of the private key should ever be able to use it and see it. Just as an aside, what I mean by key is it's basically just a string of numbers and letters that are special because they have special properties, which I will get into right now. So we've got this key pair, a public key and a private key. Everyone can see our public key. Only I can see my private key, hopefully, if I am not terrible with my security. And what can these keys be used for? Well, in real life, a key is used to lock something or unlock it. And that's essentially what these keys do. So basically what you can do with these keys is that you can use them to encrypt things. So say we have a message, which is just a generic term for a piece of data. So we have this message. What we can do is we can take our public key and we can encrypt the message, and then the only thing that can be used to decrypt it is the private key. So you encrypt it with public key, decrypt it with private key. But what you can also do is you can use the private key to encrypt the message, and then it can only be decrypted by the public key. So you're able to do it both ways. So this is a very, very important concept for you to understand. So really burn that into your memory and keep it with you forever. The reason why it's important is because public key cryptography is the basis of, a huge amount of encryption technology, and Bitcoin would not be possible without this technology. So now that we have a basic understanding of public key encryption, public key cryptography, how does this relate back to a digital signature? What is a digital signature? If we think about a normal signature, what function that serves is that it is basically a proof that someone has agreed to something or that someone is okay with something, and you put your totally unique thing that no one else can do onto a piece of paper, and that somehow proves that you're agreeing to whatever's on the paper. So that's a real life signature. A digital signature, obviously serves a very similar function, because why would they call it a digital signature if it did something completely different? That would just be stupid. Here's what a digital signature is. A digital signature is essentially where you take your private key and use it to encrypt a message. And so what is the result of that? So as we remember, if you encrypt something with your private key, then it can be decrypted with the public key. But then you might think, what's the use of that? Everyone knows my public key. Why would I bother encrypting something when everybody has the key to decrypt it? Well, what it does is that it is a signature, because if a message can be decrypted with your public key, then that means that the only way it could have been encrypted was with your private key. And the only person who has your private key is you. So then everyone has to know that you are the person that encrypted this message. So basically it functions the exact same way as a real signature, because no one else could have done it. You're the only person with your private key. So that's very, very cool, and it's the basis for signing a transaction. On the other side of it, if you use somebody else's public key to encrypt a message, that makes it so they're the only person who can see the message, because they are the only person who can decrypt it, because they're the only person who has their private key. But that's not important for this video. It's, important concept, but in terms of signing transactions, it's not what we're talking about. We've got public key encryption. That concept is cemented into your mind. We got digital signatures. You understand that now. And I'm sure you're very excited by this new knowledge that you've acquired. Now we get to the idea of signing a transaction, and you may already be able to see where this is going. Essentially, when you're signing a transaction, you are using your private key to encrypt parts of the transaction. I'm not going to get into exactly the structure of what and how it is encrypted within the transaction, because it gets extremely complicated and technical, and I could probably spend 30 minutes breaking that down. But essentially, you're using your private key to encrypt parts of the transaction, which is basically you putting your digital signature onto the transaction, and it's you signing the transaction, and so it's you verifying that you are the owner of this bitcoins associated with this public key, because you're using the private key to encrypt things. So I guess that's the whole concept. Hopefully this video made sense and was somewhat informative. Hope you enjoyed the video. Drop a like or a subscribe if you feel like you're feeling, generous today. And tune in for some more videos at some later point in the indeterminate future. And